Alrighty, so now we are going to put all of our pieces together and choose a factoring method. So based on what we see, there may be multiple methods in one problem or just one, but we have to be able to recognize it. So we're going to choose an appropriate method, and then we're going to combine methods. That's the one where I said we're going to maybe do 2 or 3. So where do you start? So when you are looking at a polynomial that you would start to be factoring, the first thing that you always want to check is a GCF. And basically everyone forgets to do this. Okay. So sometimes I will even forget that step as well. So what happens is in the end, you'll realize that you have something that was repeated and you could have taken it out. And so that, of course, was your GCF. If you have 2 terms in a polynomial, so if you have a binomial, then you're going to try the difference of squares. So you're going to look for something that's squared with subtraction and see if you can do that. If there are 3 terms, if there is a leading coefficient of a value other than 1, you're going to use the box and that like GCF stuff from chapter 7, section 4. Otherwise, you're going to do the regular X idea where you were saying what multiplies to be the last digit and adds to be the middle. So the box always happens if you have 3 terms, and then factoring by grouping always happens when you have 4 terms. So that's the steps that we're going to use as we go through each of these problems. So notice it says factor completely because, again, once you do one step, you may have to do another. So the first step that I'm going to do here is find my GCF. Before I even identify that this is a trinomial, we're going to go with GCF. So taking a look at this term, and this term, they do not all have x's in them, so that's not going to help, but they are all even. So every single one of these is going to have a 2 that could divide out of it. And so in that case, we're going to have 2, and then the remainder of 5x squared from 10 over 2, and 24x from 48 over 2, and then 16 from 32 over 2. So now we're kind of going to ignore the 2 until the end. And we're just going to focus on 5x squared plus 24x plus 16. Okay, and so that is a trinomial. And so that skips us to step 3, where we need to use the box because we have 3 terms or a trinomial. Okay, so now we get to look at this and say, okay, is there a leading coefficient that is not 1? Then we don't get to do the easy one. In this case, we now have to do the one where we say, what is 5 times 16? And that's 80. And then what are the factors of 80 that add to be 24? So factors of 80 are 1 and 80, negative 1, negative 80, which if I look at this middle term here, I'm probably not going to need the negatives, but I will be redundant. So 2 and 40, negative 2 and negative 40, that's a 4. A 3 doesn't go into 80, a 4 does. Let's see, 20 times, and negative 4 and negative 20. And I could stop there because I'm noticing that that adds to be 24, but let's keep going. So 5 and 16, and negative 5 and negative 16. 8 and 10 is next. And that's it. Going back to each of these pieces, again, we're trying to add to be 24. And so that's these 2 pieces. And so that's going to go into our box. So if you remember the box that we had from the section where there was a leading coefficient that was an a value versus a 1, we did have this kind of box looking thing here where we put the 4 with the variable and the 20 with the variable, and then diagonally put our original equation of 5x squared, 24x, and 16. Then we found the GCF of each row and column. So this column here has a 1x that's alike in them. This column has a 4 that's alike in them. Over here we have a 5 and an x that's alike, and then here is a 4. So taking a look to make sure that each of these multiply out, that means that our factors are x plus 4 from this numerator and 5x plus 4 from this denominator. That is not the answer because the answer actually has a 2. And then the result of what we just got here, which was x plus 4 and 5x plus 4. So our answer is going to be 2 out front, x plus 4, 5x plus 4. So again, 2 problems in 1. Okay, so we had to find the GCF, but that was like the first section that we had in Chapter 7. And then we had to use the box, which was more like 7-4. So that is factored completely from that trinomial. All right, next piece. Again, where do you start? Always a GCF. So looking at 8x to the 6 y squared and 18x squared y squared, yikes, that's a lot. Both of these numbers are even, so we can at least take out a 2 from both of them, right? Okay, then if we have x's, we can at least take x squared out of both of those x amounts. And since they both have a y squared, we can take that out front as well. So lots of parts of this are coming out. So 2x squared, y squared, and then your leftover, which is 8 divided by 2, which is 4. X to the 4th is left over when you take x squared. And then this last piece has a 9 from 18 over 2, and those cancel, so nothing left there. All right, so now we have 2x squared, y squared, 4x to the 4th minus 9. Now, since we have a first step of GCF, the second step is going to be the fact that it is a binomial. So since it's a binomial, we're going to do a difference of squares, or at least check for a difference of squares. Again, because there are 2 terms, or a binomial. So it is a difference, that's good. These 2 are perfect squares, so that's good, and that's an even power. So that means that to find our a value, we can do the square root of 4x to the 4th, because remember, a squared minus b squared is going to equal a minus a plus b and a minus b. So I need to find my a value, which is 2 from the square root of 4, x squared, because I divide the power in half. The b value is the square root of 9, which is 3. And so our factor is going to be an a, 2x squared, plus a b, which is 3, and an a, 2x squared, minus a b, which is 3. Bringing down the 2x squared minus y squared, 2x squared y squared, this is the complete factorization. All right, so again, GCF, and then determine by the number of terms, 2 of them, what you need to do, which is difference of squares. All right. The next one, again, factoring completely. First thing we need to do is GCF. And then after that, we are going to have a trinomial, so we will be using the box. So the GCF from each of these, notice each of them is divisible by 4, so we can divide by 4, and each of them has at least an x, so we can divide that out as well. So way out front, we're going to have 4x, and then your leftovers. 4x cubed divided by 4x takes away the 4's, but leaves you with an x squared. 16 divided by 4 leaves you with a 4, and x squared over x has 1x left over. And then the x's cancel in this last one, but 16 divided by 4 leaves you with 4. Apparently I put that too far over. All right. So again, now you're going to kind of leave this 4x out front and focus on this trinomial. So the next thing that we're going to do is part 3, which is the box, or actually in this case the x, to find out what multiplies to be 4 and adds to be 4. So if we think of the multiples of 4, we have 1 and 4, -1, -4, 2 and 2, and -2 and -2. And we want the ones that add to be +4. So that's 2. And remember that this one, you don't need more of the box in here. You just need that x method. And so these answers are the part of the term. So x plus 2 is your answer, and x plus 2 for the other piece. Bringing down your 4x that we took out to begin with, you now have your completely factored trinomial of 4x times x plus 2, x plus 2. And if you did take the time to multiply this all out, you would get back to this trinomial, which is what we're looking for. All right, then our next example, we're looking for, again, as always, the GCF. And the GCF of at least the number here is a 2. I can't take x's out of both of them, so I won't be doing that. And then y to the 1 is the lowest y power. So we will be dividing by y, which means we'll have 2y and then the leftover pieces of x squared minus y squared. And so now that we have what's in these parentheses, we are looking for a difference of squares. And again, it's a difference of squares because it's a binomial or 2 terms. And so if we're going to find out what our a value is, we take that first piece and square root it. So a is x, and b is the square root of y squared, and so it's y. So you're going to have x, which is our a value, plus our b value, which is y, and then a minus your b value, which is y. Bring down your 2y from the original GCF, and now we have our answer. All right. All right, so if none of the factoring methods work, the polynomial is what we call unfactorable. Kind of a cool idea because then you don't have to do the problem. So again, for the polynomial, if there are no numbers whose sum is b and whose product is ac, the polynomial is unfactorable. So you go through this entire list, you don't find a GCF, it's not 2 terms in this format, it's not 3 terms in this format, and it's not 4 terms by factoring by grouping, then you get to be done. All right. So hopefully from that, we've figured out how to choose an appropriate method for factoring a polynomial from 7-6. And then we combine some methods in this process to figure out what the factored completely polynomial is.